Okay guys, so we're gonna do FRQ4 here. So FRQ4, I'm gonna break it down by parts. So the first part that I wanna do is just focus on logs, right? So this whole text box, right, it's just directions and just guidance, right? So here we go. Part A, right? So it says here, A1, rewrite g of x as single log. So this section right here just means that we're just basically condensing the log, right? Because if you notice here, we have one log, two logs for g of x. Let me rewrite it over here. G of x equals to 2 log with the base of 3 x plus 4 log with the base of 3 x. So what do I do first to try to condense this? You see this number here in the front? This number, you're gonna send it to the back. The very end, it's gonna become an exponent. So now you're left with log with the base of 3 x to the power of 2 plus log with the base of 3 x to the power of 4. Now what happens here? Do I have the same base? Do I have a 3 here? A 3 here? Yes, I do. So these two become 1. So now I have a log with the base of 3, and then you have x squared times, because the multiplication comes from the addition. Addition goes with multiplication times x to the power of 4. Now you can go further, right? You can leave it like that, or you can go further and go with the log base of 3 again. But notice here that you have the same base for the, which is x, right? So what do I do with the exponents? We'll just add them, right? And what do I get from there? Log of the base of 3, x to the power of 6. And there you go. That's one of them, right? So that's literally all you have to do for A1, right? These two logs into one single log with the base of 3. That's exactly what we just did. So if I go to another example, and try to tackle the logs, look at this one, right? In this example, if I may erase this, here, you're still dealing with g of x, right? And it wants you again to condense it. But this time the base is 10, right? So now, what do I do? Well, if I see g of x, it's over here, right? So I have this 1/2 in front of the log, right? You're always checking for numbers in front of the log when you're trying to condense, right? And these numbers are just gonna become exponents. So again, you have this converting to log with the base of 10, x to the power of 1 over 2, right? Minus log with the base of 10, x to the power of 3. Here the issue is that we have a fraction. Whenever you have a fraction, you have to remember that the fraction is either going to turn into a square root, right? Or you go the other way, right? Like I mentioned before, if it's 1 over 3, you're going to put it 3 here in front of the square root. It's a cubic root, back and forth, right? So here, now you have a log, the base of 10, right? Going back to this, and just put a square root minus log with the base of 10 x to the power of 3. Just copy paste, we didn't do anything to it. So now ask yourself, do I have the same base? I have a 10 here, I have 10 here, I believe so. So now here, we're not adding no more, we're subtracting, meaning that we're going to use the quotient rule for logs. So division, which one goes first? Well, the one with the square root goes first, goes on top, and then you have x cubic. And that's pretty much it, alright? So let's try to find another one. Let's try to find another one here. Anything here? A simple one. You guys won't panic. Look at this one. This one here in this example. Alright, if I may erase this. Alright. So on both those examples, we're condensing logs, right? What happens now, we have to find a value given a log. So look at h of x. H of x has a log with the base of 4x plus log with the base of 4, 5, right? But then if you keep reading on part A, right, here it tells you that h of x is also equal to 2. So now the setup instead of just having the logs by themselves, the setup is now going to be having the logs equal to 2. Log with the base of 4, x plus log with the base of 4, 5. So your job again is to just do what we did earlier, just condense it, right? So ask yourself, do I have the same base? Yes, I do. I have 4. So these two become just 1. So log with the base of 4, x, here, you're adding, so that means here you're multiplying, alright? So now, all that is equal to, well, 2, right? So how do you get rid of a log, right? You have to remember the reciprocal, or not the reciprocal, the inverse of a log is it's going to be an exponent. In this case, we're going based on the base. The number here is 4. So you put a 4, all of this becomes an exponent. And here, all this simplifies to 1. If I have all of this set up with the base of 4, this one also has to have a base of 4. Meaning, this is not 4 times 2. This is actually 4 times 4, which is, well, 16, right? So that 16 is equal to x times 5. So what do I do from here? How do I leave the x by itself? Because again, remember, you have to find the value of x. So what do I do? Well, divide by 5, because you're multiplying, divided by 5. So x is equal to 16 divided by, well, 5, right? Unbox it in, right? Just have it like that, right? So we found the value for x, 16 over 5. Let's try to find another one. Look at this one right here. What happens is, instead of having just log, we have natural log, right? So here we have 6 natural log parentheses x minus 1 minus natural log x plus 3. So you treat it the same way, right? G of x, right? Because again, if I read the question, it tells me here, rewrite g of x into a single natural log. So these two, we have 2 of them, so that means we're going to condense into 1. Start off with the numbers. Is there any numbers in front of the natural log? The 6 is there, right? So that's going to become an exponent. So here, I'm going to write over here, I'm going to have natural log x minus 1 to the power of 6 minus natural log x plus 3. Alright, now that I have this, we can condense, right? And again, we're subtracting, meaning we're going to end up with, well, division. So here, you're going to have natural log, those two turn into 1, parentheses, x minus 1, power of 6, x plus 3. That is literally it. It only wants one single natural log. That's all you have to do. Nothing too complicated, right? So, what about this one? This one looks like more of a challenge. Alright, so again, we're just dealing with natural logs, regular logs, right? So on this one, it's going to be the same setup that we've done before, right? We have two values for each of x, right? So set one side equal to the other. So here I'm going to have 1 equals log with the base of 3 x plus 2 minus log with the base of 3 x plus 1. Alright? So now try to tackle the logs first. Is there any numbers in front of the logs? No, so we're clear. We don't have to put anything as an exponent. So now, do they have the same base? Yes, they do. So this one and this one are just going to turn into 1. Log with the base of 3 x plus 2, right, parentheses, x plus 1, parentheses, equals to, well, 1. Now, you have to figure out, how do I get rid of the log? So again, the inverse of a log is an exponent. So the exponent that we're going to use is going to be a 3, right? Or the base of the exponent is going to be a 3. So get rid of that. So 3 to the power of 1 is just, well, 3, right? So you have x plus 2 over x plus 1. So now you have a fraction. So what do I do with that? Well, I don't like fractions. Get rid of it. Multiply by the denominator. So all these right here become 1. And what I do to one side, you have to do it to the other. So now this 3 is going to distribute to the 1. and the x. So I'm left with, oh no, I don't have room. 3x plus 3 equals x plus 2. And literally you're just solving for x. So let's move the x to the right, to the left side. So this is 2x plus 3 equals 2 minus 3 minus 3. This is 0. So you have 2x equals 2 negative 1. And how do I leave the x by itself in the end? We'll just divide it. What I do to one side, again you do it to the other. So x equals negative 1 over 2. And that's it. I think that's a good review. That's a good practice, right? What about, we'll do this one, the last one. Pinky promise. So, on this one, I have to condense it, right? Because again, it says here, rewrite k of x into a single natural log, right? So k of x is right here. So I'm gonna just copy it real quick. So I'm gonna have 3 natural log x minus 1 over 2 natural log x plus 4 plus natural log 2x minus 1. 3 terms. So what do I do first? Do I have any numbers in front of the natural log? Yes, I do. I have 3 right here, which is going to become an exponent. I have 1/2, which is also going to turn into an exponent. And that last one, we're going to leave it by itself. So you have natural log x to the power 3 minus natural log x plus 4 to the power 1/2 plus natural log 2x minus 1. Remember, we have a fraction as an exponent, so this fraction is going to turn into a, well, you guessed it, square root, right? So now, what do? Well, you just go from left to right. So these two, we'll take care of them first, and we're condensing natural log. This one goes on top, right? Because we're dealing with subtraction, so that means this is cubic, right?
Squared.
Right? So you're squaring out x plus 4, right? And then you have, thank you, so you have natural log 2x minus 1. And again, here we go. If you have addition, we have to, well, you have to multiply. So these two are going to condense one more time. Natural log, and they're going to have x cubic times 2x minus 1 over the square root of x plus 4. Something like that. And if you want, again, you can distribute, but I think this should be fine, right? But if you want to distribute, we get what? 2x to the power 4 minus x cubic over the square root of x plus 4, right? And then the natural log, taking care of everything. And we'll leave it there. I think we did like 5 examples, but I think you guys get the point, right? Natural logs, condensing or expanding, right? Same concept. They show up a lot. Either you're solving for the logs or you're, again, condensing or expanding.